So, let's go ahead and get started. So my name is Gregory Kelty. I'm the father of Hope Halstead in the 9th grade. And I'm going to be running this first meeting.
Juan Martinez, if you're in the building, please come to the grade school office. Juan Martinez.
I'll be running the first meeting of the 3D Print Club. And before we open up the box and start talking about the organization of the club, I do wanted to get started with some introductions. So if you guys would, please let me know your name, grade you're in, why you're interested in 3D printing, and what ideas you have for activities that the club might do going forward. So let's start with you.
Charlie Sheedy.
And Charlie, you said you were in 8th grade? And why are you interested in 3D printing?
Because it sounded like a cool project.
Well, yeah, I agree. There's a lot of cool things that you can do with it. Do you have any ideas of activities that you would like to see the club do going forward?
Not really.
Not really right now. Okay, thanks, Charlie. Who's next?
Jonathan.
Jonathan Cruz.
Come on, I know you guys aren't fashionable.
And what grade are you in? 8th. So Jonathan, what about 3D printing are you interested in? And do you have any ideas for club activities?
Is there anything in particular you want to make?
I just came to see how it was and to see if it was like cool.
Okay, well, Jonathan, I'm glad you're here. Who's next?
I'm Oscar Silva.
Oscar Silva?
Yeah.
And Oscar, what grade are you in?
8.
Is everyone here in 8th grade? Oscar, is there anything in particular about 3D printing you're interested in? And do you have any ideas for club activities?
Well, now everybody can say that they work with the printer, so that's pretty cool. And you get cases for like iPad or
Well, I'm sure we'll have the opportunity to do that, and hopefully we'll have the opportunity to do a bunch of it. Who wants to go next?
Magali Cortez.
I'm sorry?
Magali Cortez.
Magali? Pleased to meet you, Magali. Is there anything about 3D printing that you're particularly interested in? And do you have any ideas for club activities? Not really?
I don't think they really know much about it yet, what it really is.
So Oscar at least, knows, what it is and has some ideas of what we could do with it.
Yeah. Yeah, Oscar and I visited a little bit.
And Kayla Cole.
Camberlin? No?
Yes.
Yes? And so Camberlin, is there anything in particular about 3D printing that you're interested in? Do you have any ideas for club activities? Not really? Okay, so me next. Before we open the box and start talking about club activities, I thought it was important that I give you guys a little bit about my background so you can understand my motivation for being here, and a little bit about the background of open source technology. So, as I mentioned, my name is Gregory Calfee. I went to school at the California State University of Chico. I've got bachelor's degrees in mechanical engineering, physics. I'm also a registered professional engineer. I moved to Kansas with Abengoa to be a part of their ethanol plant project, and I was the engineering director for Abengoa. For most of my adult life, I've been very interested in the idea of self-sufficiency, and that is, being able to make for yourself whatever you might want or need. And it's not an easy goal, it's really quite hard, but I do think there is somewhere that magic combination of elements, materials, and technology where you can put in sunshine and be willing to get it done, and be able to get out whatever you might want or need. So that goal has served me pretty well in my adult lifetime, except I'll be the first to admit it is a bit of a fool's errand. No one man can be completely self-sufficient. If I might, for example, be able to grow all the food and process all the food that I might want to eat, but that would be a full-time job for me. There would be no time for anything else. And even though it might be a fool's errand, I'm not ready to give up on that goal yet, because there is new technology on the rising that is going to make that sort of thing possible. If, for example, we can build machines to grow our food and process our food, that gives us more time for other pursuits. And another thing about me, another big motivator in my adult life has been kind of my objection to what I see as this growing income gap in the United States. I'm seeing, every day, poor getting poorer and the rich getting richer. And I spent a lot of my adult life trying to understand exactly what's behind that and what we can do to change it. And in that quest, I've heard a lot of stories and crazy theories, and in some ways I'm more confused now than when I started, but I do know what's behind it all is two things, secrecy and monopoly. And I used to get, depressed when I thought about the future that we're in. I used to get mad when I heard the stories of what the rich would do in order to get richer and make us poor. But in recent years, that stopped for me. It changed for me when I realized that, yes, there is things that the average person can do to make a big difference. And it's really not that hard, but it starts with two things. First you have to accept personal responsibility for your freedom or lack of it. And number two, in the words of Gandhi, you have to be the change that you want to see. If you want to fight against secrecy and monopoly, it's easy. You take an attitude of openness and sharing. And to fight against monopoly, you devote your time to the organizations that are working to promote options instead of limit them. And that's how I got involved in the open source movement. Does anyone here know what the open source movement is? No? Okay. Well, the idea of open source is simply this. Technology isn't something that's owned by an individual corporation. It belongs to all of humanity. And anyone who wants to take the initiative to learn it and apply it is free to benefit from it. We've got the time, so hopefully I won't bore you, but I do want to tell you a little bit about the background of the open source movement and how it all got started. As far as I know, the open source movement got started in the early 1990s. And in the early 90s, personal computing was just starting to really take off. You know, every family started having a personal computer. However, there was really only one choice of operating systems, and that was Windows. Early on, there were, you know, Apple computers, but those went dormant for a while, and, you know, for a long time in the 90s, your only choice of an operating system was Microsoft Windows. Now, in Silicon Valley, there were a couple software developers who were specializing in the machine interface, who decided they wanted to do something about it. So they started a movement called Project GNU, and these software developers started writing free software for man-machine interface in computers, compilers, the shell, and a whole toolkit of programs. And so, as I mentioned, this was free software. They put it out under what they called the general public license. And they protected their work under what they called the copyleft. Now, copyleft is different from the copyright, and that under the copyleft, the idea is there's free software being made available to you, and you're free to use it and do with it whatever you want. However, this software did take time to develop, so in order to pay it forward, they just asked that whatever you create using the free software, you also make available for free. Now, this GNU toolkit was, you know, a really good set of tools, but it was not a complete operating system. It was lacking the machine drivers, the software that actually controlled the inside of the computer. In the meantime, over in Sweden, there was a guy named Linus Torvald, who was who was a computer scientist, and he was following eagerly the development of the 386 computer. You guys remember or know what a 386 computer is? Probably not. The earlier generation was called the 286, and the first generation was the 8086. So the 386 was including some new things that had never been done with computers before. And this computer scientist, Linus, was pretty excited about it. And at his first opportunity, he went out and bought a new 386 computer, took it home, and wanted to start using these new features, and lo and behold, he was not able to do it. Why? Because the computer was running Microsoft Windows, and Microsoft Windows didn't allow him access to that architecture. It just wasn't there. Since Microsoft was a monopoly, they had no incentive to change. And since Linus knew this, he wasn't about to wait for Microsoft or somebody else to produce the software for it. He decided he was going to write his own. And starting with the disk drive controller, he started his own little movement. Now, do you guys know what a floppy disk is? You don't? Okay, good. That was the first bit of machine code that he wrote for controlling his new 386 computer. And as he went along, he published his work on the web in a blog, and wherever he had working software, he put it out free for others to use, so that they can help him find and fix any bugs that there might be in it. Now, as people saw that Linus was making real progress, he started getting quite a few followers. People joined in, helping him to write this machine code for controlling the 386 computer. And after a short time, maybe about a year, Linus finally had the software that he was looking for. And the story might have ended there if it wasn't for other software developers who were following Linus's work and the work of GNU, who realized that, well, you can take this GNU toolkit and Linus's kernel for machine drivers and put them together and have what actually was a working operating system. It was far from a complete operating system, but it was good enough. And from that point on, all development of the Linux operating system went forward on that platform. And that way, the Linux operating system lifted itself up by its own bootstraps to become, a brand new operating system, and quite a powerful one at that. I don't know if you guys know, almost every web server on the web today is running Linux. And its development didn't stop there. In the last couple of years, there's been some new distributions of Linux made specifically for this. This is called a Raspberry Pi. You guys know what that is? So it's a computer card. It has a CPU and a GPU, and in fact, it's actually a fully functioning computer. It's not super powerful, but it is at least as powerful as a powerful computer from 10 years ago.
What did you call it?
Raspberry Pi.
Okay.
So the Raspberry Pi was developed by a couple guys in England, and their motivation was to put a platform out there where kids can learn more about the actual mechanics of computers, the actual hardware, and learn more about the programming. And often today, kids don't really know how to program computers. They have it and use it, but don't really know what's inside and don't know how to program it. So they started this movement, and it gained quite a bit of support. A lot of people developed new distributions for Linux, specifically for this, and there's actually industry out there that got behind it, like Wolfram Mathematica decided they're going to make their program available free to anybody who has a Raspberry Pi, and that's a really powerful piece of software. You can do quite a lot with Mathematica. They're not the only ones, because it's open source. What gets developed for it is available free for all to use, and so the source code has to be open, and that's really how you get the term open source. So not only is the Raspberry Pi a good learning tool and learning platform for kids, it's also taken off recently in a couple new directions, and one is as a platform for hobby robotics. You can take 2 or 3 of these and put it together on something the size of an RC car and program it as a robot, and people are really excited about that. And one offshoot of the hobby robotics is 3D printing. It's very simple. So that's a little bit about my background and the background of open source. And as to the question of why I'm interested in 3D printing, well, as an engineer, of course, and a do-it-yourselfer, I'm very interested in the idea of a rapid prototype and being able to make whatever I want for myself. And for ideas for the club, first idea that I had was one of the things we can do in order to get anybody who wants exposure on using a 3D printer is not just use this for prototyping or a widget here or there. I think if we get behind it, we can really turn this printer into a manufacturing machine. Crank out a lot of objects that people might be willing to buy. And that way, the club can start earning money for itself. And if the club can earn, say, $350, that would be enough to buy the materials and print out the pieces you would need to make a whole new 3D printer. And this would be a printer that just belongs to the club. I think that's probably an attainable goal and one we're pursuing. But it would really need the commitment of the entire club. Is there anybody here who'd be willing to commit themselves to trying to raise $350 for the club so we could build another 3D printer?
If you're not going to, you don't have to, but if you come to art, I want you to be in the club. This is gonna be good.
Oscar, this is your thing.
This is your thing, Oscar, come on, buddy. And I think I had 2 others that told me they wanted to be here, but were gone. One's in high school, and I think the other one's in 8th grade.
Okay, well, that's good. We'll have to look at, you know, really the logistics behind doing this. I think if we are able to print 3 things per day during the week, that is, somebody comes in the morning and starts printing, and it's finished by lunch, and somebody prints something at lunch, and somebody prints something before they leave for the day, that we can probably, over the course of 10 weeks, and with a reasonable selling price of the items that get printed, make enough to get the $350 needed to build another 3D printer. Yeah, Charlie?
How are we going to sell them? Like, are we gonna have like just sell them in the school, or are we gonna go to people's doors, or?
Well,
We can
it would-
advertise.
Or like during the games, you can have Rolla stand and people from other places.
Well, I don't know how other clubs, you know, do things, if they have bake sales. What this would be is a make sale. We make items, you know, 3D printed items, and people come and check it out.
Can you give us
Just
an
like-
idea of what items, you know, what kind of things do you think we would be making?
Well, so Oscar mentioned a case for an iPad, cases for phones. I'd like to have a new case for my BlackBerry Pi, and if there's other kids with a BlackBerry Pi, maybe they want to buy one. There are a lot of really neat items on, as I mentioned you, Thingiverse.com. Have you guys, anybody been on Thingiverse.com? Kim, are you able to open it up so the kids can have a look?
That's lucky.
So besides cases, there's, you know, figurines that, you know, kids might be interested in. There's a couple neat boxes, one in particular I want to try. There's really, I don't think we have to look very hard on Thingiverse.com before we can find some things that we here would be interested in learning how to print, and other kids would be interested in how.
You don't have to pull that down, it'll just shine right on the board if you'll just erase your name.
Sure.
Charlie, you wanna get the lights? Sure. So do you wanna operate?
So,
Yes.
sure. No, I haven't spent a lot of time here yet. So, I don't know really how to navigate this. I mean, so here's bracelet. This is, looks like this cube, there's a picture frame.
Would you like Rubik's cubes, you like puzzle cubes?
There's, under the featured collections, chest sets, bracelets, birdhouses, some boxes, figures, usable items. Here, if you guys haven't seen this before, I'll point this out. This is called the Prusa 3D printer. And this was developed by another open source 3D printing organization called reprap.org. reprap.org. So if you get the chance, I think it'd be worth your while to take a look at that and see what's really behind the open source 3D printing.
Is that the one with the tray underneath? That like has the design?
Yes. With this design, the tray moves around in 2 dimensions, and then the tool that does the extruding moves up as it goes. This one looks like it's printed from plastic parts, and the design for this is available for free on reprap.org, and people are free to, of course, make any improvements that they want to make, and if they make an improvement they think is good, they put their design out, and that's also free for others to copy. And the design has evolved quite a bit over the years. This is still the standard, but there's what they call the Delta configuration that's gaining a lot of momentum. And we'll see. My 3D printer is a little bit different. There's really lots of different configurations out there, each with their pluses and minuses. I know that there's a lot of other collections here that I'm not seeing right away. So here's a phone case, nameplate, sculpture, there's a usable battery charger.
So could we program it in to do like Rolla pirate stuff?
Well, yeah,
Or-
absolutely. So, like something like this is, a keychain. If the pirate logo is not already available out there, someone will have to do the CAD program. But that's not that hard. So the CAD that is being used most often with 3D printing is Google SketchUp, because it's free. I have experience with AutoCAD, and I could do it in AutoCAD, but I would want to download Google SketchUp and learn how to use it, because it's probably the software that most of the kids here use. So does anyone here have experience with Google SketchUp? It's free software. I would encourage you to download it and see what it's about, because if you have that software and another free software called Slicer, you can take whatever you create to make a print file and print whatever you want to design. So, all right, here's some examples. I'd really encourage you all to get on thingiverse.com and take a look for yourself, and come back to next week's meeting with an idea of something on Thingiverse that we can download and start printing and possibly sell at our first make sale in order to make some money for the club. Also, I'd really encourage you to get on reprap.org and learn a little bit more about the history of 3D printers and see if there's any printer in particular that you think is one that you might want to try building for the club.
That is nice. Cool. Can you build furniture with this?
Well, you could go with just about anything. It's not now. It would have to be furniture that's built out of pieces that could be printed. bigger piece, you need a bigger printer. Now, this printer can build something that's 10 by 10 by 10. A hamster wheel? Well, I'm sure we could, and somebody might have already done it and posted their print files on thingiverse.com. So, I would really encourage you all to start looking there, and if it's not there, and it's something you really want to do, because I have got some background with, CAD, and I'm sure I can figure out this slicer program. I'd be happy to work with you to make a print file that you could use to print it. And further, and once that print file is made, I would really encourage you to post it on thingiverse.com, or if anybody else who wants to make it can.
You know what we could do for the big sound stuff, like Miss Clark was saying, like the Rolla pirate sign, we could make a whole bunch of stuff with the Rolla pirate sound.
Look at this, they made a pen that's got names on it. Do you like the pirate pen?
So, yeah, I really think there are a lot of options, but if we're going to, make things that, kids are gonna wanna buy, that's certainly something that we need to consider. Now, one of the things that I'll go ahead and mention now, in the box does come with this first spool of plastic that you can use for printing. It's just a clear PLA plastic. It doesn't have any colors. So what I'm willing to do is buy the first 4 rolls of plastic, whatever colors we want to start using, and donate that to the club. But once that's used, I'm expecting the club is going to use the money that it earns in order to buy the next rolls of plastic. So if we're wanting to do Rolla logos, I would suggest maybe 2 of the colors that we buy are yellow and green. Does everybody agree with that?
Mm-hmm.
Okay, so that leaves 2 other colors that we can start using. Besides just solid colors, there's even glow in the dark. There's plastic with a bit of wood chips in it that make it look like something that's wood. There's lots of options, and I almost want to say it's worth you guys taking the time to look, but if we want to get started as early as next week, I have to put in the order now. So maybe let's just start with yellow and green, and then there's 2 more colors. I like the idea of the glow in the dark. Does everybody else agree on glow in the dark? Yeah, okay. That leaves 1 more color. Any suggestions?
With black? She suggested black, maybe. What do you
Well,
guys-
yeah, black is a good color. So, all right, yellow, black, and green it is.
Wait, you guys want black? Is that black fine?
I like
Black's your favorite color? Is it?
Oscar.
Well, because green and black or yellow and black is sometimes we use that for Rolla colors too, and not just the green and the yellow, right? Huh?
Alrighty. So, I bought this several weeks ago. I haven't opened it yet because I wanted to open it in front of you guys so we can all start learning together. Are you guys ready to open the box? I can pull this table out there, or we can stand around to take a look. Maybe I can, how about, instead of you guys all getting up, let me just come to you. So, this model is called PrinterBot. They have several different 3D printer kits. This particular one is called Simplex Metal. They have another popular kit that's made out of wood. I like the idea of the metal printer. Let's take a look. So, right on top is the bill of materials. Looks like everything's checked off. Metal components are the base, metal bed, metal arm, bearing clamp. Includes the filament, which is the plastic used for the printing. There's a laptop power supply. There's a bag of bearings. There's a bag with wires. There's what they're calling a universal bag. It has pulleys, screws, couplers, sensors, a sensor power adapter, micro USB cable, the hot end, and the hot end is the tool that actually is going to work. The hot end is melting.
That's cool. That's cool. What?
Fan and some tools. There's 4 motors that come with it. To move in 3 dimensions, you need 3 axes, and so one motor for each one of those axes. And it's really a 4D printer, not a 3D printer, because it takes time to print. And so the 4th motor controls the spooling of the film. Here's a bag of hardware. There's something they call the extras bag. There's what they call the extruder bag, and metal Delrin bag, and the rods and the electronics board. So you can see here are the rods that the bed moves up and down on. There's a threaded rod for moving the hot end up and down. This looks like the computer board. This is very similar to the Raspberry Pi, but not exactly. They've come up with their own version of it. There's other versions out there being used, called the Arduino. They're all very similar to the Raspberry Pi. And these are the motors for controlling. These are called stepper motors, and they're able to control because on the inside of this case is a little plastic wheel with divisions and an optical sensor. And the optical sensor and divisions let the controller know how much the motor has moved. If it wants to move 2 steps, you can see it has moved 2 steps with the optical sensor. And these are pretty standard. You don't have to buy it from a kit. Hobbyists all over the world are using